It is a closed loop system, so it's one of the first testbeds to be in a closed loop.
I recently had the opportunity to chat with 5 early career researchers about their exciting practical work in molecular communication. This was in Erlangen, Germany for the 2023 workshop on molecular communications. In this series of videos, I'm sharing what they had to say about their presented work, how the technologies could be used in applications, and what they'll be working on next. This video features Maike Scherer from the University of Erlangen-Nürnberg in Germany. Maike presented a testbed that uses different wavelengths of light to write and read messages embedded in special proteins.
My name is Maike Scherer. I'm from the FAU, Erlangen-Nürnberg, and I do my PhD at the Institute of Bioengineering. It was a flow-based testbed where we had a closed-loop pipe system. Basically, in traditional MC testbeds, you have a problem that your signals get interfered over time. And so we are tackling this problem with media modulation. We have a protein called Dreiklang, which is a green fluorescent protein variant. Using different wavelengths, this protein can be reversible switched. So the switching is induced by a light stimulus. With these different wavelengths, we can write, delete, and read information. So using Dreiklang, we can convey binary information. This was the first testbed that we implemented using media modulation, and of course it is a closed loop system, so it's one of the first testbeds to be in a closed loop. As our signal molecules are propagating through the channel, we don't have to induce them in any way because they are already present, and we can convey information from the outside because our transmitter and eraser are located outside of the channel. As we can erase information, we don't mitigate our signal. Right now, it's actually that it's so flexible. This is just the starting point. So in the future, we could think about like branching our pipes or using different diameters to mimic in-body applications. This is like also future perspective for this testbed. We are also working on another MC system that is targeting anomaly detection, and the testbed could also be used investigating this setup. So this is the starting point where we can like go into every direction. If you're interested, we also already published a preprint on this, so you can find it on arXiv and have a look.
Okay, great. Thank you very much.
Thank you for having me.
That's all for now. Thanks for watching. You can like the video and leave feedback in the comments. I will be sharing more conversations from the 2023 workshop on molecular communications in a later video, and these will be combined in a playlist. Consider subscribing to stay up to date with releases, or if you'd like to see more research highlights and tutorials on biophysical communication engineering. See you next time.